to perfect problem 6 for math 95. So we're supposed to add these guys up, and then later we're going to add these guys up. So what we'll need to do before we even get started, or something that'll make it a little bit easier, is to find the prime factorizations of these big numbers here. So I'll start by doing that. I think the easiest way to find the prime factorization of a big number like 900,000 is to kind of create this little tree diagram. Let's see, 900,000, we could break that up into 9 times 100,000. There's other ways you could break that up, but I think that's the most natural thing to see. Then 9 is 3 times 3. And 100,000, let's see, because there's 5 zeros there. That's 10 times 10 times 10. 5 times, so times 10 and times 10 again. So these are prime numbers. We can't go any further, but each of these are 2 times 5. Probably going to run out of room here, but you kind of get the idea. This is 2 times 5, and this last guy here is 2 times 5. So what we have here is the number 2 written 5 times. So this is 2 to the 5th times we have the number 5 written 5 times. We have the number 3 written twice. So maybe 2 to the 5th times 3 squared times 5 to the 5th. And if I do that exact same thing for 7290, let's see, 7290 is 729 times 10. Gets us started. 10 is 2 times 5. 729. That one's a little bit tricky. You might know ways to figure out that this is divisible by 3. It's actually divisible by 9 also, but I think the easiest thing to see is it's divisible by 3. And the way you can get that is a number is divisible by 3 if when you add up all its digits, you get something divisible by 3. So 7 plus 2 is 9, plus 9 is 18, and 18 is divisible by 3. So what we get is this is 3 times something. To figure out that something, you might need a calculator, or you might be able to do it with long division or in your head or whatever. But anyways, this is 243. Then 243 is divisible by 3 also. Ends up it's 3 times 81. We knew it was divisible by 3 for the same reason. If you add these up, you get something divisible by 3. 81, maybe you see that's 9 times 9. And 9 is 3 times 3. So what we have is 7290 is 2 for this 2. And then 1, 2, 3, 4, 5. We have 6 3s. So 3 to the 6th. And then 1, 5. Okay, so we have the prime factorizations. Now we can finally start tackling these problems. The first one, I think the way I taught you guys in class is to set this up with a good radical and a bad radical. So what I'm saying here is all the stuff that's a perfect square we'll put over here, and all the stuff that's not we'll put over here. So let's see, we have 2 to the 5th. So maybe I'll put 4 of those 2's over here in the good side, and 1 in the bad side. So 2 to the 5th, let's put 2 to the 4th over here and 2 over here. 3 squared, put both of those over here. 5 to the 5th, I'm going to put 5 to the 4th over here, and 5 over here. And then x to the 9th, put x to the 8th over here, and x over here. So what we've managed to do is 2 to the 4th, the square root of that is 2 squared. The square root of 3 squared is 3. The square root of 5 to the 4th is 5 squared. And the square root of x to the 8th is x to the 4th. We have that times the square root of 10x. So let's see, if we multiply these all to put them together, one of the 2's times one of the 5's is 10. The other 2 times the other 5 is 10, so that gives us 100, and times 3 would give us 300. So we have 300 x to the 4th times the square root of 10x. But all we've done is simplify one of these. Now we'll have to do that again with this guy. So maybe this guy here, split this up into good and bad. Let's see, on the good one, what do we have? We have just 1 2 here, so we can't put anything over here. We'll have to put that on the bad. 3 to the 6th, we can put all 6 of the 3's over here. and 1, 5. We'll have to put that over here. And x to the 9th, kind of like we did before, we'll put x to the 8th on this side and x on this side. And what that gives us is 3 cubed times x to the 4th. And then this one here we'll leave as the square root of 10x. And so 3 cubed, 3 times 3 is 9, times 3 is 27. So we got 27x to the 4th times the square root of 10x. And what we've done is we've now simplified this guy and this guy. And what you'll notice is we have 300x to the 4th of these root 10x's and 27x to the 4th of these root 10x's. So we can now add those together. And what we get when we add those two up is some other amount of 10 to the x's. We'll have to figure out what is 300x to the 4th plus 27x to the 4th. All that ends up being 327 of these x to the 4ths. So our final answer, 327x to the 4th square root of 10x. Whew, all right. Now, we're still not done. We got to repeat all that stuff one more time. But what's kind of nice is the method here is going to be very similar to the method here. We're going to start by taking this guy into good and the bad. And it'll be very similar to what we did here, except this is the 4th root. So we'll have to be a little bit careful on what we pull out here. So the good radical will be the 4th root of a bunch of stuff, and the bad radical is the 4th root of a bunch of stuff. So let's see. For the 2's, we had 2 to the 5th, so we can put 4 of those over here and leave the last one over here. For the 3's, we had 3 squared. Be careful, now we can't put 3 squared over in the good. We'll have to leave them both in the bad, because the 4th root of 3 squared isn't something we know. It's not a perfect 4th, so we can't put it over here. All right, and 5 to the 5th, we can put 4 of those guys over here, and then the remaining guys left over here. And x to the 9th, we can put 8 of them over here, and 1 of them over here. And the reason we split these up the way we did is we can now figure out the 4th root of all this stuff. The 4th root of 2 to the 4th is just 2. The 4th root of 5 to the 4th is just 5. And the 4th root of x to the 8th is x squared. So we have that times the 4th root of, let's see, 3 squared is 9 times 2, well, 2 times 5 is 10, and 10 times 9 is 90. I think that's the easiest way to see what we got going on in here. So what we have is 2 times 5, 10x squared times the 4th root of 90x. This is an x to the 24th. Careful, this is x squared, and then this is the 4th root. Okay, now we just did that for this guy, so now we got to do that for this guy. So let's see here, we got good and bad, and what we want. Let's see, what's 4th root on the good side? This 7290, we had a 2, which has to go in the bad because it's not a perfect 4th. We have a 3 to the 6th, so we can put 4 of those guys over here, and then leave the other 2 over here. And then we had a 5. So that's stuck over here on the bad side. And then x to the 9th, we're going to put 8 of them over here and 1 of them over here. And the reason we put what we did on the good is because the 4th root of 3 to the 4th is just 3. The 4th root of x to the 8th is x squared. And that's all this times the 4th root of, let's see, 2 times 5 is 10, and 3 squared is 9. So again, we got 90x. So what we need to do is, I'll just copy this exactly so my lines match up, is add up 10x squared, 4th root of 90x, plus 3x squared, 4th root of 90x. And we can do that because now we have the same thing in the radical here. So we write that radical once, 4th root of 90x, and now we have to add up 10x squared and 3x squared. That gives us 13 of these x squareds. So our final answer, 13x squared, fourth root of 90x. Whew, that's finally the end of this perfect problem.